Satyabama Institute of Science and Technology.
Today I am going to take normalization and types of normalization. Myself G. Kavitha, Assistant Professor in CSC Department, Satyabama Institute of Science and Technology. First one, define normalization. The normalization is nothing but it's a process of organizing data in database to avoid data redundancy. Redundancy means repetition. The data repeated to it will be avoided, and then insertion, update, and then deletion, anomaly. Anomaly is nothing but that is error or bugs, anything. So the process of organizing data in database to avoid data repetition, update, delete, and then insert errors and bugs. This is the normalization definitions. And then process of organizing data into table in such a way that the result of using database are always unambiguous as intended. That is unclear information only having the database. So it will be processed and remove it out. And then such normalization is intrinsic. Intrinsic is nothing but part of nature to relational database theory. It may occur effect of duplicating data within the database and result creating the additional tables. This is the normalization definition. The next one, types of normalization. The normalization is having 6 types. First normalization, it is called as 1NF, or it's called as another name 1NF. Second normalization, the another name 2NF. And then third normalization 3NF. Third one is 3.5 normalization. It's called as a Boyce-Codd normalization. And then fourth normalization form 4NF. And then fifth normalization form 5NF. This is the types of normalization. Let's see detailed explanation of types of normalization. The first normalization criteria are, the first point, eliminating repeating groups in individual tables. Eliminating repeating groups in a individual tables, and then create a separate table for each set of related data. And then third point, identify each set of related data with a primary key. Primary key is nothing but unique identifier in the record of the table. That is the primary key explanation. Unique identification in the record of the table. So first point, eliminating repeating groups in the individual table, create separate table for each set of relational data, identify each set of related data with a primary key. First normalization example, the table name is table product, and then 3 attributes describing the table product. One is product ID, color, price. So I am giving the 5 information. This table not in first normal form because the color column contains a multiple value. Repeating values will be eliminated. This is the first rule in the first normalization. So the product ID 1 is having 2 values in the color column, and then price it will be defined, and then fourth product ID also is having 2 values. So the color column contains a multiple value. We will transform into the first normalization. See this? After decomposing it into the first normal form, look like this. See this? Product ID, price. I am taking the product ID 1, 2, 3, 4, 5. And then price 210, 150, 110, 260, 100. Similarly, the product ID color. See, the product ID 1, it will be repeated because the color value in the same column is having 2. And then I am splitted into right. So, first product ID is having color black, one product ID is having red. So, there is one normalization rules will be satisfied. And then next one, next type, second normal form. Second normal form, a table is said to be 2NF. Both the following condition is satisfied first NF, and then no non-prime attributes is dependent on the proper subset of candidate key of the table. Here non-prime attributes is nothing but it's not a part of primary key. Primary key is a unique identification of record in the table. So it's not part of in the primary key, that is considered as a non-prime attributes. That is depends on the subset of any candidate key. Candidate key also similar definition for primary key. Primary key, that is the field or set. It's representing the unique identifications in the record of the table. That is the candidate key definition. An attribute that is not part of any candidate key is known as non-prime attributes. So, in the attribute, it is not a part of candidate key. Candidate key is a unique identification. So, that is considered as a non-prime attributes. This is the second normalization form. So, this is an example of second normalization. See, product purchase details and then customer ID, store ID, location. This is the three attributes. We are giving the 5 data again. This table as a composite primary key. Why it's a composite primary key means customer ID, store ID already it's a primary key. So, I am taking the 2 column into this query. It will display the same numbers, display the both the attributes values. So, that's called as a composite primary key. Customer ID, store ID, it's having the key attributes locations. Then in this case of location dependency on store ID, which is part of the primary key. So, next table after decomposition into the second normal, it's look like, see, customer ID, store ID and then store ID, location. So, second normalization will satisfied in this table. After that, third normalization, a table design is said to be 3NF if both the following condition is having. Table must be in 2NF. 2NF means already satisfy the 1NF and then extra point, that is non-prime attributes depends on the candidate key. That is also satisfied in the 2NF and then transitive functional dependency of non-prime attribute on a super key. Super key is also similar definition for primary key. Super key definition, unique identification in the row in the table and then primary key, foreign key is the record in the table. This is row in the table. This one similar variations. Super key should be removed. An attribute that is not part of any candidate key is known as a non-prime attributes. These points already seen in the previous slide. In other words, 3NF can be explained like this. A table is in 3NF if it is in 2NF or for each functional dependency x tends to y. At least one of the following conditions have: x is super key of the table and then y is primary attribute of the table. One is super key, another one is a primary key. An attribute that is the part of one candidate key is known as prime attributes. So, this condition is satisfied means that is 3NF. See the one example. Here in the table, book ID determine genre ID and genre ID determine genre type. Genre means gender. Therefore, book ID determine gender type by gender ID and we have transitive functional dependency. See this? This is the after decomposition, it into third normal form, it's look like this. And then Boyce-Codd normal form. Boyce-Codd normal form is the 3.5 NF. After that 3 and 4 in between it will develop 3.5. Its names comes Boyce-Codd normal form. The BCNF is strict than 3NF. A table compliance which is BCNF. If it is in 3NF, for every functional dependency extends to y, x should be super key of the table. Here key student course. Functional dependency student course tends to teacher, teachers tends to course. The problem, teacher is not super key but determine course. See, after decomposition it Boyce-Codd normal, it's look like this. Student course, it will segregate and then course and teacher. So, the Boyce-Codd normalization form satisfied. Fourth normal form is the level of database normalization where there are no non-trivial multi-value dependency and other than candidate key. It built on the first 3 normal and Boyce-Codd normal. It stated that in addition to database meeting the requirements of BCNF, it must not contain more than one multi-value dependency. This is the fourth normalization definition. And then example, key student, major, hobby, MVD, that is multi variable dependency here, major and hobby. So after decomposing it into the fourth normal form, it looks like this. Fifth normal form, it's similar. The before fourth normalization satisfied, after we can decompose table further to eliminate redundancy. Redundancy means repetition, errors and bugs are anomalies, and when we rejoin the decomposed table by means of candidate key, we should not losing the original data or any new record set should not arise. It's simple word, join two or more decomposed table should not lose record nor create new record. The fifth normalization, here key seller company product, MVD seller. Seller is having dependency, seller dependent on company product, the product is related to a company. After decomposition into fifth normalization, this output will be produced, and then next, this is the final fifth normalization. After decomposition, fifth normalization, your table look like this. Thank you.